Everyone, this is 5.5 integration by substitution. Okay, so until now, right, we've been doing those relatively simple integrals, even though they may have looked complicated, right? So if I had, say, 3x to the third plus 7x squared minus 3 over x, and I'm supposed to integrate it with respect to x. Right, it wouldn't be too bad, right? We could just kind of split it into three different integrals or three different fractions, and then, right, based on our rule, the rule looked something like this: x to the n dx. Right, we add one, and then we take that exponent, so it's going to be x to n plus 1. We take that exponent and we put it at the bottom. Okay, and then we have the plus c. If we have a regular integral, not definite integral. Okay, and see, right, so we know how to do things like that. We know how to do simple trigonometric functions, like, say, right, integral of cosine x. Right, so let's look at that one. Cosine x dx. Right, so the way I think about it is, right, so if I want to take, I need a function here, something, right, plus c, that if I take a derivative of that, I would get back this. Right, so let me erase that. Right, so derivative of what function gives me cosine x? Right, so that's sine x. Okay, so that's the solution. And then, right, if I had it the other way, maybe you could try to figure it out. Right, so sine of x dx. Right, so again, right, so you're thinking, I'll pause the video and see if you remember how to do this, right? So what do we put here so that we get that sine of x? Okay, so the answer is negative cosine, right? So negative cosine of x. And because derivative of cosine is negative sign, but I need positive sign, so I need that negative in front. Okay, so we know how to do this, something like this. But if I had, right, if we were given an integral like this, so I have cosine of x squared, right? So it's not cosine of x, but cosine of x squared. Right, so this actually is quite difficult, right? But I want to show you, I want to explain this integration by substitution just kind of by looking at this particular function, cosine of x squared. So we will, so I will show you how this works, how that substitution works, with this particular example that actually will not work. But yeah, I don't know, just bear with me. Okay, so substitution, I hope you've seen, U substitution. It's called U substitution. Let me write it. So U substitution. Okay, by substituting, right? So maybe you've seen something like this, right? So x to the fourth, maybe minus x squared minus 6 equals 0, right? So you need to solve it. So the way to solve it, you would substitute that u for x squared. And then after you've done it, you would have u squared minus u minus 6 equals 0. And then this is pretty easy to solve. So the idea is similar, right? So u substitution. And actually in this case, you would take that u and you would again substitute for substituted for x squared. Okay, so let's try it and see what happens. Okay, so I'm taking x squared and replacing it with u. So I have cosine, and then I have u. The problem is that now I have dx, right? I don't, in my function here, right, as you guys see over here, I don't have x, right? But I need to, it still looks like I'm integrating with respect to dx. So what I need to do, I need to change the dx to du. Okay, so the way I would go about it, I would take this u equals, right, so I have that u equals x squared. And I would simply differentiate both sides with respect to x, right? So it would be du over dx equals, with respect to x, right? Differentiating with respect to x. So this is just 2x, right? So don't get confused, right? So now I'm taking derivative, right? So I'm moving that 2 to the front and subtracting 1, right? So one of the difficult parts, right, in calculus or beginning calculus is that, right, students confuse taking integrals where you add 1, taking derivative when you subtract 1. Okay, so let's finish this. So derivative of x squared is 2x. Okay, so now what I have is du over dx equals 2x. I can solve this easily for dx and replace this dx with whatever I get from this. Okay, so let's solve. So solving for du, so solving for dx. Okay, so dx equals du over 2x. Okay, so at this point, I'll take that let me see. Alright, so I take that expression for dx and I will replace this dx with it. Okay, so I have integral cosine u, and then I have du over 2x. Okay, so remember at the beginning, right, of this problem, when I posed that problem, I said that it's impossible to do, or it's very difficult. Right, so now you see, I hope you see why. So I have cosine of u, I have du, but I still have x in the equation, right, as my variable. So now imagine that I was integrating a function that looked like this, cosine x squared. Now I would have 2x dx. Right, so look how different, right? So this function is different than this one. And the difference is that 2x. And, you know, we need that 2x because when I go about this whole, right, business of u substitution, right, the way I did it here, I will end up with 2x in the denominator, right? And that 2x in the denominator will cancel this 2x. So let me kind of summarize what I said. Right, so we have two functions. The first one was cosine of x squared dx, and that's the function we tried initially to integrate and it didn't work out. And we have a different one. This one is cosine x squared. And now I have the 2x dx. right? So this one is easy to solve, and I'll show you in a moment how. And this one, I think it's solvable, but it's difficult. Right? I'm not sure if it's done in Calc 2 or maybe later. Anyway, maybe it doesn't even have a solution. I don't remember. Right? But the green one definitely has a solution. So let's see how we can solve it. Right? So I have that. I'm looking at this. Right? And I'll go about it exactly the same way. So I go u equals x squared. Now, I cannot remember, right? I know that I will need that dx equals some stuff, right? So instead of like replacing it right now, okay, instead of putting that u in here, I'll just take a derivative of this, right? And find that dx. Okay, so let's do it. So left side, right? Remember we're integrating with respect to x, so du dx. And then the right side, and maybe I'll do it a little bit slower. So d dx x squared. Alright, so du dx equals 2x. Now we're solving for dx. And we get du over 2x. Okay, so I hope so far so good. Let me maybe make it green. Okay, so now we're here. Right? I will replace x squared with u, and I will replace dx with expression for dx. Okay, so let's do it. So I have cosine u. Then I have my 2x, right? And 2x doesn't go anywhere, right? I'm talking about this 2x. Okay. So I have du over 2x. Okay, so now I can cancel these two, and this variable, this additional variable that I had in the equation, that x, is gone. So we're good to go. Alright, so finally we have integral of cosine u with respect to u. Okay, so that equals to sine of u plus c. Okay, so yeah, the last step, right? Because now my original problem didn't have u, right? It had x. So I need to replace back and that u with x squared. Okay, so we're just doing this. And we get sine x squared. This is x squared plus c. Okay. So this is how that substitution works. Yeah, we'll do more examples and let's see. Okay, yeah, so this needs, this kind of unclear, right? But this needs parentheses, right? So x squared is under that, inside the sign. All right. Yeah, let's do that other, let's do another example. Let's call it example 1, actually. Storm. Okay, yeah, so solve. Compute the integral, and this is what we have, right? So we have x cubed plus 1 square, and now I have 3x squared times 3x squared. Okay, so I want to point out this at 3x squared, right? So this is, if we had just this, right? Kind of like that with that cosine, right? So if I had just, right, like before, I showed you that this is very difficult to compute, right? So here, similarly, right? If I didn't have this, if I just had that, it would be very difficult to compute this. And the reason is that if I'm replacing I don't know, some expression, maybe this, right? Maybe the whole thing, maybe just x cubed. We'll think about it in a moment. I will be taking derivative of that, and I will end up. Let me make it the other way. After I've taken derivative, I will end up with 3x squared, and that 3x squared is going to be in the bottom, right? So, and then, right, I'll be able to cancel these two, right? This and that. So that kind of shows you like how you should be thinking about it, right? So say if I asked you, if we had let me give you a different example. So let's say we have 7x squared plus 1 to the 7th, right? And then we had 14x dx. And then we had, so let's say this is right, problem number 1. And problem number 2. It would look like this. 7x squared plus 1 to the 7th power dx. Okay, so I would ask you, well, you have right, two problems here. Problem 1, problem 2. Which one would you prefer to solve, right? Which one is easier, or maybe solve just one of them, right? So that would be the question. And well, the answer is, even though problem number 1 looks more difficult, right, it'd be easier to solve than this problem. And the reason is that, right, I have that 14x, because I'll be replacing with u probably this expression. And the derivative of that is 14x. And that 14x that's coming from this will end up in the denominator here. And I'll be able to cancel these. But here, it's not going to work, right? Because I'll have that 14x here. And there is nothing to cancel that 14x in the denominator. Okay, so I hope you understand the idea. And let's go back to our problem. Okay, so problem was x cubed plus 1 squared, and then we have the 3x squared that we need, right? So this we need that 3x squared. Okay, so let me close the window. Okay, so let's go back to this problem. So now we're looking for some expression, for an expression that we can replace that, the expression we can replace with u. Yeah, so there are a couple of options, right? You could, I don't know, you could try this whole thing maybe. You could try this expression, or maybe just x cubed. I don't know, you can try a couple of those things. Well, what I'll do, I'll replace this with u. Okay? So let's do it. So we have u equals x cubed plus 1. And now, right, so if we replace that expression with u, yeah, we would have this, so u squared, and then this, and dx. So I know I need that, replace dx, so let's do that. So taking derivative of both sides, right, so du is going to be the left side, and the right side is just 3x squared. Yeah, and here it is, right? So that 3x squared that I said we need. I mean, this 3x squared will cancel this, right? So we needed this one. Okay, So now we're solving for dx. So dx is du over 3x squared. Now we go back to the original and replace this with u, right? And then those 3x squares will cancel out. So let's do that. I have integral with u squared. Then I have that original 3x squared. Then I have du over 3x squared. Okay, so we cancel these and we ended up with an integral u squared du. Okay, so this one is quite doable. Right, so again, you kind of need to think, what are we doing exactly? Well, we're adding 1, right? And dividing by 3. So that's the power rule for integrals. So that's going to be u to the third over 3 plus c. Right? Indefinite integral, so we need c. Okay, so now the last step is to replace u to the third with the original expression. Okay, so let's do that. So we have x cubed plus 1 to the third over 3 and plus c. Okay, so that's the solution.